Hello everyone, today we're taking a look at a container with most water, which is the solution is an interesting variation on the popular two-pointer algorithm. So you're given an integer height of length n, there are n vertical lines drawn such that the endpoints are I of 0 and I of height I of 0 and I of height I. Find two lines that together with the x-axis form a container such that the container contains the most water. And you want to return the max. So here we have a height. So this is our array with all the different heights, 1, 8, 6, 2, so on and so forth. The output is 49, being that the maximum area here is 49. So in essentially, we're trying to find the biggest rectangle, the rectangle with the biggest area. And the formula for area of a rectangle is, as we all know, length times width. So in other words, we want to maximize the length and we want to maximize the width to get the maximum area. So how are we going to do that? Well, we don't really know the lengths until we traverse the array. So setting that aside, how do we maximize the width? I mean, you maximize the width by setting left and right pointers to be as far away from each other as possible, which means that you set the left pointer to index 0 and you set a right pointer to index n-1, where n is the length of the array. So as soon as you start, you're going to have a rectangle with a potential width of 8, or no, a width of 8. And then the length is going to be something. So this is our very first area. So what is the length actually going to be? What is the, I guess, the height of this rectangle going to look like? Now let's imagine that you kind of just removed all these inside rectangles, and let's see what this would look like. So you have a height of 1, and then you just have a floor because we removed all the other rectangles, and then you have another bar here with a height of 7. So 7 and 1. Now let's imagine that you tried to fill this up with water. So you fill this up 1 unit, that's good. Now what happens as soon as you try to fill it up with 1 block of a second layer? Then it'll overflow out because it's limited by this first column. And it's limited by this first column because the height is less than the other column. In other words, the maximum length of the container is just going to be the minimum length of whichever the two of these are. And in the case that they're equal, then you can just kind of, set it, just increment whichever one. But if this is equal, or if this left one is less than, then, and this is the limiting bar, then that means that we want to try and increment the left bar and see if maybe we can hit something higher. And if we hit something much higher, then we're going to be able to update the area with something that's even greater, even though we drop the width by 1. So just to make it, see if that makes a little bit more sense. So if this is 1, then it's much better that we increment this left one, because we could possibly hit a 3, or we could possibly hit a 2, or we could possibly hit like another 1. It doesn't really matter, but the worst case scenario is that you kind of just do the same. It's much more likely that you'll get something bigger. But if you were to increment this one, if you were to decrement the right one, then if you hit a 6, you would still be limited by this 1 right here. If you hit a 5, you would still be limited by the 1. Even if you hit a 10 or 100, you would still be limited by the 1. So you want to change the limiting factor as frequently as possible, right? You only want to update the limiting factor. So the first area is going to be the minimum between index 0 and index n-1, which is 1. Which means your area is going to be 8, and then after you increment it once, you're going to increment your left pointer once, and then you'll get that left is now 8 and 7. So your left and right is now 8 and 7, which means the minimum is 7. So the length is 7, and the width just got decremented by 1, so another 7, so this is 49, and every time you hit a new area that is greater than the current area, or current max area, then you're just going to update that variable. Just a quick look at the complexity. So the complexity for time, because this is two-pointer, we're just doing a 1 pass. At max, we'll hit every index once. So this is going to be O of n, constant time. And for space, we're not actually instantiating any new variables, arrays, or anything like that. So this is constant space. So pretty good solution. All right, let's take a look at how it looks in the code. All right, the first thing we're going to do is set our left and right pointers. So left is going to be 0, and right is going to be the length of the array -1 to get our very last index. And then we're also going to set a max area variable, which is going to be our solution that will return at the end. Now our actual algorithm for two-pointer is going to look like this. Left is less than right. We don't care about when left is equal to right, because that'll give us a width of 0, which will just have an area of 0, so that doesn't matter. If height left is less than or equal to height right, and this is the case where we would want to increment the left, then we are going to update the max area variable. with whatever the max is between right minus left, that's going to be our width, times height left. And because height is less than or equal to, height or left is less than or equal to, the height left is going to be our limiting bar. And then we're going to update that with max area, and then we can just increment left. Otherwise, and this is going to be the condition where right is less than left, then we're going to update max area again, but going to change it very slightly. Our width is still the same because it's always just right minus left, but we're multiplying it this time by height right because this time height right is our limiting bar. And we can just decrement right. And after this, that's pretty much everything. All we have to do is return max area, and this should be the solution. And yep, that's it.